We can explain this with an example because it will be easy when we use an example. Okay. Yes. Here x of NTS. Let I'm using a sample. That is one. This is one sample. This is another sample. This is another sample. Okay. These are samples. Let it be. I will just denote its values. This is 2. This is 3, and this is 4. Okay. It may be different values. This just values. Okay. So I'll use another color. Okay. First sample is 2. So x of NTS, that is coming to when we come to the block diagram, just show that. Okay, this is a block diagram. This is x of NTS അല്ലേ? ഇതാണ് നമ്മുടെ x of NTS. Okay, x of NTS ലേക്ക് നമ്മൾ വരുന്നത് ഏതാണെന്നാ പറഞ്ഞേ? This is 2 അല്ലേ? 2 ആണ് നമ്മുടെ coming signal. So I'll explain it here. It will be better, I think. So the incoming signal is 2. Then this comparator will add this with the x dash of NTS. So what will be the output? E of NTS will be, yes, initially this x of NTS is considered as 0 and n is equal to 1. Okay, n is equal to 1. So x of 1TS will be coming. This is 1. So x of 1TS will be coming. So we have to consider n is equal to 1 and E of NTS, error signal, is equal to what? Error signal is equal to 2 minus 0. That is equal to, 2 minus 0 equal to 2. It's simple. Then while going to the quantizer, it gets a quantization error. Here we are just considering quantization error as 0. So what will be the output? EQ of NTS. This EQ of NTS will be equal to this 2 plus 0 is equal to 2, and this 2 will be encoded. Am I right? It's just an example. This value will be differing. Okay, this EQ of NTS will come here, and this x of NTS will also come here at the comparator, and this will be added. It's shown in this equation. Okay, and will produce this x of NTS. And what will be the value of x of NTS? Okay, it's just x dash of NTS plus EQ of NTS. What's that? 0 plus 2. What is that? Is equal to 2. Quite simple. Okay, this 2 will be the predictor filter input, and it will then calculate what? X dash of n plus 1 TS. Okay, we have seen the equation. X dash of n plus 1 TS is nothing but, it's a simple equation. I'll show that. That's in the next slide. Okay, that is xq of NTS plus q of NTS. It's simple. xq of NTS. What is xq and xq of NTS? It's shown here. Plus q of NTS. This value and q of NTS will give what? What is q of NTS? Q of NTS. What is that? It's equal to 0. So this output will be x q of NTS plus q of NTS gives 2 plus 0, that's equal to 0. Okay. I'll use another color, like I think better color is brown. I'll take brown color. Okay, I like this color very much. So next cycle is going to take place. So n will become what? N will become 2. Okay, this n will become 2, and this, sorry, there was an error. 2 plus 0, 2. 2 was there. I forgot to write here. That's nothing but 2. 2. Okay. It was my error. Sorry. Okay. Here 2 is coming here. This next n will become 2, and this 2 is coming here, and the 0 is replaced with 2. Okay, and the next sample is, for n equal to 2, the sample is 3. So this 2 gets cancelled and it will become 3, and here the error signal will become 3 minus 2, that's equal to 3 minus 2 equal to 1. And the quantization error, as we have already said, it's equal to 0. So what will be the EQ of NTS? It will be yes, 1 minus 0, 1 itself, and this will be encoded. Okay, it will be encoded. Then this 1 will come here, and this x dash of NTS, what is that? 2. This 1 and this 2 will, 1 plus 2 will be, the output will be not 2. These are errors. 1 plus 2 is equal to 3. We will get 3 as output of this comparator, and this 3 will be going to this predictor, and it will calculate the value of the next value of the previous sample. Okay, so what will be that? 3 plus q of NTS. What was that? Q of NTS was 0, so it will become 3 plus 0, and this 2 is cancelled. It's 3. Yes, we have got the value 3. Okay, like that it will be similarly for the sample 4 also. I'm not explaining that much, it's just EC1. Okay, so let's move on. Now we have to think about Dpcm receiver. It's quite easy. It's a demodulator circuit. Okay, we can see demodulator circuit here. It's containing a decoder, a comparator, a prediction filter. Okay, here B of NTS is the coming signal that has been transmitted by the transmitter, and it's getting decoded by the decoder, and then it's going to the input of the comparator, and then this comparator will produce the output. Am I right? There is an LPF at the output. Here there will be an LPF, that is low pass filter, and this low pass filter will produce an analog signal. We have produced a digital signal. This is getting decoded and discretized, and then this samples are being we have used this sample to pass through the prediction filter, and then this So the Dpcm receiver circuit is very easy. It's only having a decoder, comparator and prediction filter, and there will be an LPF also here. So here EQ of NTS, that's the error signal that has been produced, and X dash of NTS is the value that has been predicted by the prediction filter. XQ of NTS, this is the value that has been produced. This is sample that has been produced at the output, and this is the analog. We will convert this to analog signal using an LPF here. This XQ of NTS is again going back to the prediction filter, and this is used to calculate the value of the previous sample. Sorry, not calculate, to predict the value of the previous sample and calculate the value of the present sample. Okay. What is XQ of NTS? It's nothing but X dash of NTS plus EQ of NTS. It's nothing because we use a comparator here, so it will add up the EQ of NTS and X dash of NTS, and we'll get XQ of NTS as the output. This decoder will produce the digital signal to analog signal. That is, it will not analog, decoder will convert the digital to, it will decode the signal. Digital will be converted to discrete signal, and this will be again then converted to analog signal by using this LPF here. That's not shown in this block diagram. That's only the thing we are getting here. If the incoming signal is 2, then the XQ of NTS may be 0, then 2 will be coming here, and EQ of NTS is equal to 0, and X dash of NTS will be 0. So we will get, I will write it here. Let not B of NTS, EQ of NTS is equal to 2. Okay, it is equal to 2, and XQ of NTS, X dash of NTS is 0, and 2 and this X dash of NTS will togetherly form the XQ of NTS. What is that? XQ of NTS is equal to 2 plus 0, that's equal to 2. You will get the output as 2. Am I right? This will be again going back to prediction filter. Am I right? This will be going back to prediction filter. That's all about the Dpcm receiver. We have transmitted a single signal, that was 2. Am I right? Similarly, for other samples also there may be some differences in the sample values, but this process will be going on. Okay, it's all about Dpcm receiver part. I think you all understood the portions very much. So if you have any doubt, please do mention in the comment box, so that I will be able to clear your doubts using the comments. And if you want any more description or PPT or any PDFs related to this article, just comment on the comment box and I'll be sharing that to you. And doubt related topics, you have to comment so that I'll be able to record videos on that topic and will be shared with you in simple manner, so that we can make electronics very easy. Thank you.